Yeah, let's get started.
Yeah, let's get started.
Okay.
Hooray!
We got introduced to you mainly through the channel StatQuest. Like we started learning ML, and your videos were very helpful in that sense. Very
Okay.
nice explanations. So, could you tell us how did it come to your mind that you should start this YouTube channel, and how did you find StatQuest?
Yeah, I'll tell you the whole story. Um I used to work in a laboratory. It was a genetics laboratory and there were lots of people doing experiments and I was the numbers guy. I was sort of, the one guy doing all the data analytics. And I love statistics. I think it's super fun. And when I got into my first statistics class, they started talking about variation. And that's when I fell in love with statistics. And what I loved about the concept of variation, it was like everything's different. Not only is everything different all the time, we can quantify that difference and we can use that quantification to our advantage. We're not just making guesses, but we're making educated guesses. We can make the best guess possible, given that there's all this variety. And I guess that concept alone made me fall in love with statistics. Uh, that being said, I was not great at statistics. I was sort of there's a phrase that we have called the one-eyed man is king in the land of the blind. So all of the genetics people, they just hated math no matter what, and I was at least willing to do it. I wanted to learn statistics myself, and I also wanted to teach what I learned to my coworkers because I didn't want them to think that it was magic. I don't know. I was excited about it and I wanted them to appreciate it as well. And so I'm a very visual learner, so I came up with sort of like visual ways to try to understand things. And I just thought about them for a long time and kind of tried different attempts. And eventually I came up with a way to understand R squared. Like I came up with a simple PowerPoint presentation. So one of my coworkers encouraged me to put it on YouTube. And so one cool thing about putting a video on YouTube is that instead of me teaching sort of when it's convenient for me, they can learn when it's convenient for them. And so I put it up on YouTube and with the goal of like, just doing this for my coworkers. I had no illusion that anyone would ever in their right mind want to click on a video about R squared just for fun. Statistics can be used in almost every field. And that's great, right? You can use, statistics and machine learning and these tools can be used almost everywhere. And that's cool. But the bad side of that is because the teachers don't want to bias you because it can be used in every situation, they tend to teach it in a very abstract way. Or at least the teachers I had tended to be like, okay, imagine you have an urn full of marbles, instead of like, okay, imagine you have a test tube full of cells from different mice or something like that. Or my friends and my colleagues, my people I was working with, they couldn't relate to those abstract concepts at all. They were mouse geneticists because they loved doing stuff with mouse and genetics, and so I needed to talk in that language of mouse genetics in order for them to understand, using concrete examples that they could relate to rather than really abstract things. So I made these videos for them. And what happened in the first year, I got 9 views and I got 2 subscribers. And that was a huge success for me. I was absolutely like beyond my wildest dreams because there's only 10 people in the lab. And that means almost all of them watched my video. I mean, that's almost 100%. I got 90% success rate, right? And that's about as good as you can get these days. It sounds like a silly point, but actually, I think it's a really major point where for me, YouTube was a way to solve a specific problem. And I did solve that problem. I wasn't trying to become famous. I didn't imagine that like 4 years later, I'd be talking to people in North India that are at this coolest IIT ever because they've got a hiking and trekking club that I want to join. I never imagined that's where things were going. Then other people started watching it, and then I was like, well, I don't know what to do now, and I don't know what topics to cover now. And it's funny because nowadays I that never is a problem. I've got a long list of about 1,000 topics I need to cover, and each day somebody suggests something on my channel. But back then I needed some guidance as to what to do next. And I was talking to a friend, and he said, "Do you know what a random forest is?" And I said, "I have no idea. I've never even heard of a random forest." And he goes, "Well, can you help me figure out what it is and how it works? Because I just read a manuscript that had a random forest in it, and I have no idea what they're talking about." And I said, "Okay, I'll work on it." And so I found some books and I found some online articles and I learned about decision trees. And from there, I was able to learn about these things called random forests, which are basically collections of decision trees. And I started making videos about what I'd learned on the way. So StatQuest was actually my quest. It was my journey of learning things, and it continues to be my journey of learning things. So I got into machine learning. I'd never even when I was in undergraduates, I remember people or I had some friends take a class in machine learning, but it sounded too advanced for me. It sounded really scary. It sounded really mathy. I'm not great at math. And so I was like, I can't take that class. And so it kind of blows my mind that I'm now kind of an expert in the field. I didn't see that coming because I think that's what makes my channel kind of special is I'm not good at math and I'm very visual. And so I try to make these videos that you know, aren't super heavy on the math and are very visual because that's the only way I can learn. I have to see things. And I think that's sort of I think a lot of other people must relate to that in some way. And I'm not just alone in my inability to be great at math. Um, so that's the story of my channel is just kind of me kind of plugging away, learning stuff and being excited about things and just trying to solve problems along the way.
On the behalf of everyone, like we would
Yeah.
like to thank that person who convinced you to put that video on YouTube.
Yeah,
Like
yeah.
when we had to study PC and LDADL recently before semester exams, an hour earlier, your
Yeah.
videos were a savior.
Fun. So, how do you approach when you want to simplify a complex statistical concept to explain it to a broader audience?
Yeah, so the first thing I do is I try to come up with the simplest example that illustrates what that concept is doing, right? So, like with a linear regression, say like I want to explain linear regression. I think to have a reasonable explanation, you need 3 data points that aren't exactly on a straight line. The advantage of having 3 is that you can then do the math by hand. When you have as small a data set as possible, you can walk through the math one step at a time. And when you do it that way, it's a lot more approachable and understandable because everything's real and nothing's really abstract. You're not just saying, well, given given data set X1, X2, all the way to Xn, the purpose is to calculate, the sum of Y sub 1 minus X sub 1, Y sub I or something like that. When you do it that way, it becomes very abstract and people are like, what's going on? But when you actually do the math, people can see the actual numbers and they realize the other thing that's nice about actually doing the math is you realize that the math isn't that hard. And so even if you have someone who hates math and the last time they took math was when they were 10 years old, well, they can still understand these concepts if you just go through it in the most simple way and you get rid of all the fancy notation. And the other thing that's really helpful is when you have 3 data points, you can then draw it as well. Like I can draw my 3 data points and then I can actually draw the residuals, the difference between the point on the line and the actual point. And when I can draw it, even if they don't really follow along the math, if that's too much, they can still just see it. So that's my thing is keep the data set as simple as possible. So to get to that point of keeping it as simple as possible, if we just had 1 point, we couldn't illustrate linear regression. It wouldn't make any sense at all, because any line could fit 1 point. So 1 point is too few. 2 points, if we have 2 points, well, any line that can connect 2 points, we can always just draw a line between 2 points. And again, that doesn't really illustrate linear regression and best fitting a line and residuals and those concepts. But when we have 3 points, unless they're in a perfectly straight line, and they usually rarely aren't, and you just have to bump one even if it is. If say like they're on a perfectly straight line, just make them not perfectly straight. But what we have is 3 points, and all of a sudden we can't just connect them with the straight line. And now we've got to figure out, well, if we can't just connect them with a straight line, how do we fit a line to this data? So 3 is sort of the minimum number of data points we can use to explain linear regression. But the catch is they have to have a non-linearity. So we start off at a low point and we move to a high point, and then the third data point then goes back to a low point. So we've got like up and then down. So linear regression can just sort of like fit 2 of those 3 points, but a neural network can fit all 3. And again, we found this sort of minimal data set. So that is the very first thing I do. And when I do it by hand, I learn a ton. I'm like, oh, I see what's going on now. And especially if I'm drawing pictures as I go, it becomes a lot more obvious, and I learn a lot more about how all the pieces fit together. And then the math stops being so scary. I'm easily intimidated by complicated math equations. And so it stops being more scary and more like, oh, you're just a big, like, fuzzy teddy bear because you're just doing kind of easy things that I'm comfortable with. And so that's my trick for sort of breaking down complicated things so that other people can understand it. And I'll be honest, I'm not very good at the math and just looking at an abstract equation and going, oh, I know what that does. Some people are good at that, and that's awesome. I don't have that gift. And so I turn that weakness, my personal weakness, it turns into my strength, right? It's kind of my superpower all of a sudden because I'm no good at that stuff. I have no choice but to break it down into small pieces and just do the math by hand, and that's my way of figuring it out.
So yeah, on a different note, we're all big fans of your, very unique music and intro style. We just wanted to know what's your inspiration behind every intro video. Each one is unique, and it's very fun to listen to.
Yeah, so there's a couple of things going on. So wow. So there's a pedagogical purpose, a teaching purpose, which sounds insane. But what they do is they're silly. And a lot of people, not just me, I've discovered, are scared by data science and the math involved, or all those things. These are intimidating topics when I feel like I have to learn this. I've got a test on it tomorrow. And so I have these little silly songs. One, to kind of like say, hey, it's actually not that serious. It's not that crazy. Look, we're going to do this together, and we're going to have fun while we do it. And you're going to learn it. Don't worry about it. So part of the silly song is just to help people relax. The other thing is making a video for me is a very time consuming process. I'm just a very slow kind of like, it takes me a long time. I'm slow. It just takes me a long time to understand things and get the big picture and understand the main ideas. If it's a short video, I can do it in a month. But some videos I've worked on for years. That PCA video, that took years to make. I had to think about it forever. And work on it and draw pictures and then throw all my pictures away and start again. It took years to do. And so what I do is I make my slides, I do my research, I make my slides, I record my stuff. And then when I'm done, it's time to party. And that's when I record my silly songs as a way to kind of celebrate the end of a very long process. And it's my way of saying I'm done and I'm wrapping it up. It's just a way of to me, it's like a transition, and it works both ways. It helps people transition into a state where they're ready to learn and they're excited about learning, and they're confident, or they're encouraged that they're going to learn. So it helps people transition into that state, and also helps me transition from working on this to now I'm ready to work on something new.
Right, that makes a lot of sense. Can you tell us something about Lightning AI, its goals, your role
Oh
there?
yeah, I'd be happy to. So my videos, if you watch them, you'll know that a lot of them focus on sort of the theory side of like the concepts, the main ideas. This is the big picture. Um, but I don't have a lot of videos. I have some, but I don't have a lot that's sort of like, this is how you would actually do this analysis. This is like, here's a dozen ways to do principal component analysis given different data sets from different fields. I've never really done that much. And but I'd wanted to I wanted to do that for neural networks. I wanted to show people how to do not just pretend little toy neural networks that have that fit a curve to 3 data points, which are silly, but useful for illustrating concepts, but not useful for doing anything helpful. I wanted to be able to teach neural networks not just as a concept, but also how they're really done in real life. And this has been bothering me for a long time. This is what I really wanted to do. And then Lightning came by and they said, well, if you make using the cloud super easy, then you basically make teaching how to do real neural networks super easy. Because the hard part of neural networks isn't necessarily like building the neural network, because you can actually just copy and paste. You can get ChatGPT to give you code for the neural network for all, the code is actually the easy part. The running it on 50 GPUs and getting your data all set up, that's the hard part. And that's the part you're going to spend all your time on. And this company came up with a really cool solution. But the idea is it's in your web browser. You can start writing code and you can run it. And it's relatively easy to then access some GPUs if you want to run it. And Lightning gives people free credits. If you just run stuff on a CPU, you can do that for free. So there's no risk there. And then they give you free credits for using a GPU every month. And so for free, you can be like, let's just see what happens when I run this on 4 GPUs. And when you're using 4 GPUs, all of a sudden you can start using really large data sets and training really fast. It's pretty amazing. I was training something. It was like it was a language model. It was translating English to German. And I did it just on a CPU, and it took 48 hours. And then I ran it on a GPU, and it took 5 minutes. And so if a company gives you like 10 hours of GPU credits or something like that, you can actually get a lot of real work done for free. And they manage it all. What's cool is you write your code once. And the other thing I like is Lightning AI also creates something called PyTorch Lightning. And what's cool about PyTorch Lightning is if you just run PyTorch on its own, that's fine. But if you want to run it on a GPU, you have to modify the code to run on GPU. And if you run it on 10 GPUs, you got to change the code again. So it's real hardware specific. PyTorch Lightning generalizes all that stuff. So you write your code once, and then you just tell it how many GPUs you want, and it takes care of all of the rewriting and dealing with things for you. So that was key, made that easy, and it made accessing GPUs in the cloud super easy. And that's 90% of the problem. And so what I've been doing for them is I've been making tutorials, and I've been porting my tutorials so that you can use their cloud interface and you can play around and go, oh, this is actually really easy. And my goal is to ultimately build all the way up to where we're doing like a Chat GPT style model of that's like actually doing really cool things. And you can learn about sort of cool optimization techniques on the way. And so that's my thing with Lightning AI. So I like to say, uh, I like to make hard things easy to understand. And what Lightning does is they make hard things easy to do. They've taken out the difficulty of writing code that runs on GPUs, and they've taken out difficulty of accessing and utilizing GPUs, and they've eliminated those as problems.
So do you follow the developments in AI in general nowadays?
I try. I do the best I can, but it moves so fast that I don't know if I'm an expert or not. Um, but I try the best. I try the best that I can. So if you have questions, I'm more than willing to try to entertain them.
There are like two.
Sure.
AI is a new field, so there is academia where research happens in universities, and in industries also research happens, and they have a lot of resources also.
Yeah.
So there are two parallel branches for the this new field. So what are your views on this? Like, how should like the do you think there's a tension between academia and industry, or they help each other, or what do you think about the relationship?
I mean, they definitely help each other. That's for sure. Right. I don't know if this is going to answer your question, but one thing that's cool is I started a new podcast. I haven't released any episodes, but I've recorded 7. I'm about to record my 8th episode in a few hours. And once I have these 8, I'm going to start editing them and I'll start releasing them. But what I'm doing is I'm actually interviewing people in industry and academics about what they're doing and how they're using AI and machine learning. And what I've discovered is that in industry, a lot of people are using very simple models. You know, I mean, some people are doing complicated things, but a lot of people are just doing linear regression uh, and calling that AI, which is fine. I think it's legit. But they're just using linear regression. They're not like deploying the latest, greatest, generative AI model or something like that. They're not. I mean, some people are doing that, but I think it's actually a relatively small subset. I mean, we see that when you get online, you're like, oh my gosh, look at these cool pictures that these people created using this AI tool. It's easy to think that everyone in industry is doing that kind of amazing stuff. And it's actually a relatively small number of people. And everyone else is just doing like bread and butter techniques that have been around for a long time and not necessarily the latest, greatest thing. And so I think that's sort of drives some of the point that it's not enough to just to know what the latest, greatest thing is. You actually have to know what the old stuff, old techniques are. You can't just like, I'm the best neural network person on the planet and forget all about simple things like linear regression because chances are that's what you're actually going to be using or something along those lines. And so, yeah, so, but in academics, everybody wants the latest and greatest. So I've found a lot of academic people are talking about, they're the ones that are sort of like researching how far can they take neural networks. And so there, a lot of the academic people are doing the more complicated methods and things like that. But that's good that we can learn from them and sort of take it from there.
So to be probing this question further, how do you approach a problem, say, instead, like if you'd like to look at a problem in genetics from a statistical perspective, how do you go about trying out models on it, or how do you go about exploring the data?
Yeah, so it's a great question. I have a rule, which is plot the data as the very first step. And that can sometimes be challenging, right? That's actually how I learned principal component analysis to begin with, because I was like, how do I visualize this data? I've got too many rows and too many columns, PCA was there for the rescue, and I was able to that, and I did it on this. They gave me this experimental data, and I was able to say, oh, these mice were normal, and these mice had a special diet. And using PCA, I was able to separate them and go, you did the experiment correctly, right? They separated the way we were expecting. What the hypothesis was if we gave these mice a special diet, they would grow faster than the control mice. And when we just look at all the metrics with PCA, I could see 2 clusters that were separate from each other. And I don't know if they were growing faster or slower, but I can at least tell you they look different. And so PCA was a big thing for me. But it's also like, what do you do when you have like PCA usually just works with numeric data, right? And sometimes we can have sort of mixed, or what they call tabular data, which has numeric values, but it also has discrete values, like, I don't know, favorite color, or if there's other discrete aspects of these mice, if they're just keeping track of like coat color, like the mice have their fur, maybe that's a factor, so they keep track of that, and they tend to have just discrete types of fur, like just like we have relatively discrete types of hair color. And so what do you do when it's not like a continuous gradation from one value to the other? um and what methods do we have for that? And that's actually gets us back to my favorite thing ever, which is this method called random forests, which allows you to visualize tabular data. And so I'm a big fan of visualizing, and I try to come up with, I look at the data and go, oh, it's all numeric values. We can use PCA. If it's got more complicated things, maybe we can try this random forest sort of visualization approach, or dimension reduction method, and see what happens. And so there's that. But also I also ask about the experiment itself. I want to learn about the experiment. I want to learn where the sources of variation can come in, the major sources of variation. Are they doing the entire experiment in one day? Or are they doing it over the course of multiple days? Are they getting all, or maybe a better way to put it, or are all the measurements collected on the same day? Or do they collect some measurements on Tuesday, and then Thursday somebody else comes in the lab and collects different measurements? That's going to change things, right? That's going to change how we're going to analyze the data. And I also want to know what the experiment means. What's the big picture? What's the goal? Why is this experiment important? I like knowing all that stuff. I don't know if it's helpful for um all the time for doing the analysis, but I think it helps me as a statistician to feel like there's a purpose in my life. And I'm not just a calculator or a robot. When I was in the genetics lab, it was cool to realize that um what we were doing. One of the things I worked on, one of the projects I worked on was uh, something that happens in women. So in women, so men have an X chromosome and a Y chromosome, and women typically have two X's, but not always. Sometimes you'll have women with just one X chromosome, and for the most part, that's fine. But it turns out when you just have one X chromosome, you get the flu more often, and there's some other complications that occur. And I worked on a group where we were studying sort of like, what can we do to counteract this? Can we overexpress a gene? So when you have two X chromosomes, you get sort of double dose of things, and when you just have one, maybe you're just getting half of much of each gene that you need. And so maybe we could find a way to overexpress. And it was cool knowing that the work I was doing could potentially help people, and there was a bigger, broader picture, and it wasn't being used for evil or for other things. It was nice to know that there was a real helpful benefit that would come from me doing this t-test or something like that. It's like, I just love that big picture, and knowing why I'm doing what I'm doing, because it gives me meaning. It gives, and it helps me get excited about getting out of bed.
Yeah, this is kind of insightful. Well, when most of us train a model, we just pick a model, we just pick a data set and try to fit the model in the data set. So that's what we mostly do. So the
You're
data.
not solving a real problem though when you do it that way, right? You're not being helpful.
Mhm.
And so it's important to go, what could I do that'd be helpful? What could be useful? Um, I mean, it could be useful for you to learn, and you could pick a model and a data set and just try to learn, because it's important for you to learn, right? Because maybe later that fact that you learn something will be helpful. But it's a little better if you can find a real problem. And I've always been sort of real curious. And the very first job I got out of college, I worked in a hospital, and they put me like far away from the hospital because I was a computer guy, and they didn't think I needed to be near the hospital. Like, what does a computer guy need? We just tell the computer guy what to do, and the computer guy does it. and that's fine, but not for me. So I would wander the hospital, and I'd find things to do that I thought were helpful, and I'd work with physicians, and I was real fortunate that I could do that, with it, because they were like, because at the time, like the thought of a computer person being in a hospital was really novel, and they're like, well, it's against the rules, but let's just see what happens if we let Starmer do this, because I don't know, let's see what happens. And so they were curious too, and so I wandered around and I found all kinds of problems that I could have just been doing stuff in the abstract, but for me, I ended up helping people in the neonatal intensive care unit. So when when babies are born too early, uh, there's a couple of problems, right? Oftentimes they're not fully developed, and they can't eat on their own. They have to be fed intravenously, and feeding a baby like that is real delicate. They have to have just the right amount of everything. And it turned out that the math of figuring out just the right amount of everything was just done with pencil and paper and a hand calculator in the neonatal intensive care unit. And they would say, well, they know it needs this baby needs this much sodium. And if they have this much sodium, then they would do the math and they'd figure out how much potassium they needed to balance that out. And then they'd do all that for all the things. And it was really complicated and very error prone. And so I created like a website, that would do the math for you. And you could just type in your sodium and it would do all the math and balance everything out. And it was helpful and it was useful. And it wasn't just like silly. It wasn't just a silly song, right? It was, and so I would always see like, how can I be helpful? How can I be useful? What can I do that needs to be done? Um, I've kind of lived my whole life that way of like looking around to find out what needs to be done.
Yeah, figuring out problems and doing your own thing.
Yeah.
Good.
I'll be honest. The one thing I'll also say, I know I'm a rambler, but I'll also say I've never liked having a boss tell me what to do. I've always just despised it. And so I found that if I have some initiative, and instead of just sitting around waiting for my boss to tell me what to do, if I look around and I go, oh, this needs to be done, sooner or later the boss will realize that they don't need to tell me what to do, that I'll just figure it out. And then I like that. I like that freedom. I've consistent. I know it sounds weird, and maybe I'm special, and it's possible, but it's consistently happened to me where I've gotten a job and the boss would be like, how about you do this? And usually it's something stupid and it takes a few seconds. And as soon as I'm done, what I start doing is I start looking for other things to do. And I go, whoa, what about this? And I just start doing things and they're like, oh, this is great, helpful, and if you have a good boss, they'll be like, this is great. You're being helpful. And I'm not, you look like you can take care of yourself. Occasionally I've had bad bosses that are like, I really hate it when you do your own thing. I want to be your boss and I want to be telling you what to do all the time. And those people, I go, okay, I tell you what, I'm going to apply for another job. I've always just found ways out of those situations. And one thing that's nice about computing is there are a lot of jobs. You don't always get stuck with like a crummy boss. You have some power and you should use it to find a situation where you feel like you can be most helpful and most useful.
So is that the reason that you got into academia?
Oh, yeah. I mean, yes and no. There's a lot of reasons why I got into academics. But I'll be honest, I left academics almost 4 years ago. And I've loved that as well. And so you just have to poke around until you find a good fit, but you have to be true to yourself and be honest and say, this isn't a good fit. I mean, if you like to sit around and have people tell you what to do, then fine. I'm not going to tell you not to do it that way. But if you're someone who likes to be kind of in charge and control of your own destiny, if you want to be the boss of yourself, then you have to hunt around for that. And but do it. But hunt. It's worth it.
Yeah, just since we went through a lot of what impact AI creates and what impact statistics and and how efficient it makes general fields become, I just wanted to get a final piece of advice that you'd like to give to students like us who want to actually create an impact, who want to give back and want to do something that's not been done before.
Mm-hmm. Oh, yeah. I mean, it's along the lines of what I've been saying. Poke around and have some initiative. Don't wait for people to tell you what to do. Try things, and get involved in the process of, like I was saying with the experiments. Don't just do the data analysis. Dive in. And sometimes that means getting a little bit of domain knowledge. So, obviously I love music, but I love a lot of things. And we have these tools as computer people, as vision and language processor people. We have a cool set of tools that can be used in a wide variety of places. So find something that you think is helpful or useful, and then just show up and look around. And the first day you're going to be working there, doing something there, and you'd be like, this has nothing to do with my skill set. Um, and it's possible that won't change. But the other flip side of the coin is, if you keep showing up and you keep poking around and keep finding out how people are doing things and what they're doing and what really needs to be done, you'll start seeing how your tool set can be used in that environment. Like, no one told me that the neonatal intensive care unit needed someone to help with the math. I had to show up and say, this is amazing that you can feed these babies. How do you do it? And they're like, well, oh my gosh, it's the nightmare. Let me show you. And they showed it to me, and I was like, oh, I've got a skill set that I can use to help solve this problem and make things better. But I had to show up first, and I had to ask, and I had to poke around. And it might not have been, I mean, I showed up at the neonatal intensive care unit eventually, but it wasn't the first place I went to. So find stuff that you care about and poke around and learn what you can about it, learn what you can about the process. Intern, get experience in the field, learn the language. I feel like every field has its own language. Ours is no exception, right? AI, data science, data analytics. We've got all our own like terms and whatnot, but every field is like that. So go out and learn their language so you can speak with them, and get this, they'll start trusting you. And when they start trusting you because you care about what they're doing, when they trust you, you can start working together better. And they might be more honest and go, you know what, maybe this is what we need. Maybe this would be helpful, or this is something I have a lot of problems with. Not everyone wants to talk about their problems at the first. A lot of people, some people want to come off as strong, people that can do everything. And so you have to get to know them before they're like, show you a little weakness of like, actually, this is kind of hard. And then you're like, well, maybe that's what I could help with. So I know it's wishy-washy. What I'm saying is, it's just a lot of vague things, just like go out and try things. But I'm being honest, and I'm being serious. That's what I did. I just tried everything. I love learning. And so for me, even if something was a bust, I came away learning something, and I'd say that was worth my while. I did something I loved. But it's the only way you can really find a good fit for yourself. I mean, some people are born into it and they don't have to do it. But for the rest of us, we have to find it. And if we just sit around, we'll never find it. We have to have some initiative. We got to get up and go work in a hospital, or work, at an archaeological dig site, or go work in a music studio, or go work, in a boring office building, and just poke around and see what you can see, and find out what needs to be fixed and find out what needs to be done.
Right. So I think that's mostly it from our side. Really grateful to have you on here. Anything if you want to add at the end of all of this, most welcome.
Thank you for listening to me ramble. Oh, and we're gone out of tune, so it's not the best song, but thank you guys. I really appreciate it. It's been fun talking to you guys. I hope it's been fun listening to me. I've been talking so much. Whatever.
It has. It's been really fun
It's been a
listening.
fun experience. Yeah.
Yes.
It's been
Yeah.
Pretty much eased
Yeah.
us into this conversation. Yeah, this has
Yeah.
been fun.
Well, thank you guys. I know it's nighttime over there, so enjoy your rest of your day. And it's great talking to you. And hopefully we'll do it again sometime.
Yeah.
Yeah, looking forward to seeing you in a couple of
Yeah.
years.
That's right. I'm gonna visit. I'm coming. Yeah.
Yeah, we'd love to.
Thank
Okay.
you.
Bye.
Bye bye.
Bye bye.